start with a new topic in Python. So which is nothing but pandas. Yeah. So we'll start with this one. So pandas. So what is pandas used for, and why we need pandas, and what are different classes in pandas or objects in pandas, methods in pandas, and how do we do data manipulation on pandas and data cleaning, data transformation, data analysis, machine learning, and data visualization. How do we do all this as well? So we'll be in today's session, we are going to talk about all this. Okay, not just in one session, because it might take some time, couple of hours time, hours in sense at least some 7 to 10 hours of this thing on pandas, because this is one of the lengthiest topic in Python. But again, it's simple with all the basics and everything what we had discussed so far. Because in a way, we completed almost Python syllabus. With that foundation, this is nothing. We are already familiar with collections and data structures. And it is something like that. Already, if we had done on collections, this pandas is something like that. It is something like that. Lists are something like that. Dictionaries, something like that. Even this pandas has two basic classes. One is series and the other one is data frames. They are nothing but again they are inbuilt collections. Okay, fine, no problem. We'll go one by one here. Let's start the discussion. It's a powerful library. Generally, it is used to work with the data, to do any operations on data. This is very important. And then here we have primarily two components in pandas. One is series, the other one is data frame. So these are the two different components, which are the core components of pandas. Okay, series is nothing but like a kind of list or a array, one-dimensional array or a dynamic list, something like that. Okay, you know list, right? It's almost same, but series is a bit more advanced, we can say. That's all, simply speaking. And data frame is like a multi-dimensional table, like a two-dimensional table or three-dimensional table, like something like that. So mostly, sorry, I mentioned three-dimension, right? It's like more like a two-dimensional table, simply speaking. And that is data frame. Okay, and data frames and series are quite similar in that
அப்பா வந்து தூங்குவா.
I think I should mute. Yeah, fine, no problem. So so this is what, so series and data frames both are similar. We can convert, right, even series to data frames, a data frame to series as well. We can try that as well. So, so we can do all those sorts of operations. Got it, right? We'll see one by one. Maybe if you see the more practical examples that give us more idea. But this is overall simple, quick summaries. This pandas has two core components, series and data frames. We need to understand these things. Again, for that, if you ask me, are they difficult? With all this foundation we have in Python, these are nothing simple, because they looks more like your collections, your data structures, like our lists are your dictionaries or something like that. Okay, finally. So we'll start with series first, and we understand how to create series and how to play around series, and then again we jump to data structures. Again we see how to play with the, sorry, not data structures, data frame. Okay, how to play with data frame, and what is that data frame looks like, and how to create that table kind of thing, how to write. Data frame is collection of columns, simply speaking, rows and columns otherwise. So how to play around columns, how to play around rows, all that we see in data frames. So okay, we'll start with series first. Let's have a clear understanding of series. Then we jump to data frames and we work on data frames. So we can create series in two ways. One is creating empty series, creating a series using inputs. So empty series is simple. First thing, whenever we are working with pandas, the important thing is, so I do one thing. I just start with simple example now so that it's easy for you. These are all simple things. Series one. Okay. Now you can just see first thing always when you are working with pandas, import pandas as PD. This is the common notation people use. That PD thing you can see many places. You can go and see anywhere. People generally just create it as PD. It's not like it should be PD. You can put anything of your choice because this is just an alias. Okay. Next, after that, if you want to create an empty series, it's simple, right? PD dot. In that there is a series. You can see when you say PD dot. You can on pandas you can see many things. Right. One of those core things is series. And if you just create a, right, there are many classes even in Python, like set method. You remember, right? If you want to create empty set, empty list, empty tuple, we have used this kind of thing. Instead of that, we are using series class and creating just a constructor kind of thing here. So this methods create a series. This acts as a conversion function from any other data type to series. And if you just print it, you can see I'm printing this, right click run this. So you can see it's an empty. So when you look at this, okay, sorry, I should assign it to some variable. I cannot directly print PD. Okay, some S1 equal to now print that S1. Okay, right click and run this. Now you can see this is a series object, and you can see all these values here are empty values in this. It is showing empty. That shows that this is an empty series. Got it right? Next one after that. So that's all. This is nothing. This is simple example. No complexity, no difficulty. So that is about the first example. So how to create a series from array? Array in sense our list itself. We are all very much familiar with that, right? So you can see an example again. You can take a list some L1 equal to, you can have some values in the list, something like this. And then now I want to convert this to series, then some S2 equal to some PD dot, okay, what I can do series of L1, okay. And finally, now simply what you can do, some print of L1. Now you can right click this and run this. Now you can see this, right? This, sorry. Also, we should print what I print list, that is fine. So, but we should also print what series because we are working with series. Printing that is also very important. Now you can see there is it's good if you print both, and this should give you a very clear picture about difference between a list and a series. Whatever we have in series is nothing but it's nothing but we created it from a list. But the difference is list has internal indexing, implicit indexing, but series has explicit indexing. You can see by default series has a, so what is it here? Default indexing, which we can see here. So when we have 6 items here, the index starts with 0, ends with 5, and that is visible here. Of course, even list has indexing. All of us know very well about that. But that is an implicit. We don't see that, but we know that. And if you want to extract data, we apply index on list. But here, if you see on series, what is that here? It is by default showing you that indexing on that series. So that is difference between list and series. Means this is a bit advanced compared to list. And you can do little bigger operations on data compared to list. Of course, I don't say we can do with list as well, but this is much more simple. So that is the idea of it. Got it right. Similarly, you take one more. We can also create a series from dictionary. You can take an example of some okay, some fruits or something. Okay, you can take any example. FRUI. Okay, fruits equal to, take a dictionary something like one colon apple. Okay, something like this. Okay, two colon banana. Just taking just to show you a simple example, and three colon orange. This is a simple dictionary. Now we are creating a series from dictionary. Now what you can do to this series S3, we name this as S3, and to this series pass this fruit stick. Okay, and then print S3, print of S3. This should give you what? Third one. You observe this. Now you can see there is a change in indexing. Default indexing is it starts with the 0 and ends with the size -1. Now you can see there is a slight change when you pass dictionary as an object to series. And also you can see some difference here. You should also observe one thing. The data type of series is something when we pass list as an object, and the data type of this dictionary has something, when we pass strings as parameters. So we'll talk about all that one by one. So simple point here. You can see when you pass list as object to series, it's showing data type as int64. When you pass a dictionary with what is it here? Key as integers and values as strings, then it is showing data type as object. So you can see that change here. So, but point is when you pass dictionary as a object to series or a parameter to series, simply speaking, what's happening here? It took the index as that keys and values as values here. You can see here that apple, banana is as values and index is this, right? This is the idea. So, but the question is, what is this int64? Because inside this series, each value is integer, and the data type of integer is nothing but int64. And each value occupies 8 bytes of memory. You know, right? 64 bit means 8 bytes. And object means this is a string. For object, we are not sure how much it occupies. It depends on size of that object. String is a class, right? So that's why these are all objects. Got it right, friends? So this is the idea of what how to create a series from list, how to create a series from dictionary, and how that values are projected here when we print it, how they are projected. This is very important for us. Okay, and by default, if you don't provide any index for series, it picks the index starting from 0, ends with size -1. Suppose if you have provided, if you are providing some customized index, it chooses customized index instead of default index. Got it right? So that's how we can simply make changes, simply manipulate this series in Python. Okay, next example. After that, so we created a series from list, and So this anyhow, we try to get it. So having a customized index again. Okay, we created with pandas that, sorry, with the dictionary, that is fine. But other thing is what? Also to the list, we can have provide a customized index for series. Like for example, let us take this example. Okay, you see here, friends. So what I do, maybe you can test this. Meanwhile, you can also parallelly, what you can do is you can test this simple small examples so that you can get that clear idea while we are discussing itself. Okay, just keep testing these code snippets. Now I'm just removing all this. I'm taking one more example just to provide a customized index. How to, by default, we'll see customized index. So first thing, what is that you should do? Import pandas as PD. Okay, then you take a list here, something like 1, 2, 3. Okay, and then these are all simple things. Then print it, tell one. Then convert it to series. If you directly convert it, write PD dot sum S1 equal to PD dot series of L1. Okay, so this is default. We are creating a series by default, like with default indexing. Suppose you print this S1, then what happens? You get a default indexing with for 1, 2, 3. You can see it starts with 0, ends with size -1. Now I want to provide a customized index. So if I want to provide a customized index, what can I do? Right? Simply, you have that you can, while creating a series, what you can do, you can pass that value. Suppose here it is now L1 instead of A, change it to L1. It's same as playing around that built-in functions like conversion, this series function. Now you pass L1 and you use this parameter or attribute index. And to that index, you set the index values, that column names otherwise. Sorry. Yeah, in a way they work like that internally. But it's okay. You can also provide a customized or named index or customized index here. In this case, it is a named index, or we can call them as labels as well. Suppose now if you print it, okay, print of my series, right click, run this. You see a change here. See, earlier the series is having by default is using default indexing. But when we provide this index and when we provide this customized labels, you can see the index of this series changed here. Got it, right? It is showing XYZ. Now to play around this data, you can use this customized index. You don't need to use this default index. Suppose you see here now on this S1, let me just show you. Extracting using default values. Here what I'm doing, I'm just displaying value using default index. Suppose you see here, I say that S1 of 0, right? This is what extracting using default index. Okay. And this, now run this. Similarly here, you can also do one thing, same time. So what you can do, series of, you can just pass X and see. Okay, maybe I think you need a quote here, okay, because this is a string, right? X is a string label parameter. Now you can see we are trying to access element from series using index. Okay. Now in one case we are choosing default index, in another case we are choosing customized index. Let's run this. Now you can see here we got one, which is accessed through customized index. Same thing, right? Here also we have one, but that is done extracted to simple default index. Output is same, but the difference is what? Difference is in first case we are using default index. Here we are using default index, which is nothing but this one. In the second case, we are using customized index. Suppose here you see one more example, one more quick check. Suppose instead of X, I put here 0 itself by default. Will this work or not is one question. If it works, what would be the output? Right? So it would be, let's check it now. So you can see here, so this is should be a warning. This is not error, of course. Okay, that is fine. It is saying if you already have labels and so this approach is deprecated, will be deprecated in future versions. But for now, you can see output. One is coming, right? But this, if you want to access something through integer index, it is saying like, there is a method of ilock. So something like that, you have to use it. It's saying no problem. But I just want to show you implicitly that will be there. What is that? That index, default index still is there. That is why we are seeing here one as output for 2 times here. You can see here. Got it, right? But once you have named index, better you choose named index more than default index. Why? Because if you are creating named index, the idea is you want to depend on named indexes or that labels, not on default indexing, right? So that is the idea. Just want to show you, but this is showing a warning that this approach is deprecated. Okay. So that is the next one. So this is completed and this is also done, creating a series with a dictionary. We already did this. Maybe if you want, we can quickly check this example, right? We did already how to create a series with dictionary, simple example. Just let's test it quickly. Okay, you can see here again, this is one more series example where this is create and you can see there is a change now. Now index, your index is a string here and values are, you can see this decimals. And you can see we have named index here in simple word. In this case, this series has a named index. You can see here this all these keys named keys inside dictionary are used as named index. And values you can see here. Got it right? So we'll do one thing. First, you can test this as well. Test this code. First, you test this. And then we can do one thing. I'm removing all this. And now you can see here. This gives you much more clear picture. This time, by default, always if you pass dictionary as a parameter to series, always keys are treated as index, as named index or named labels. You got it right there. Named labels in suppose you put integer, then that integer is treated as index there or customized index. Got it right there, simply speaking. So if you run this, you can see the output here, how it look like. And the values, it always shows the data type of value. These are all decimals, right? That is why it is showing float 64. When it is float 64, probably it should occupy 8 bytes of memory. Each value occupies 8 bytes. All these three values occupies 8 3 is 24 bytes. Likewise, you can calculate the size of your data structure as well, that series or anything. Okay, this is the idea, friends. You can also test it now. So just keep in mind, what is that? When you pass dictionary, always keys are used as index inside series, and values by default would be same as values. Okay, that should be fine. Just sharing this as well. Test this. Okay. Next after that, this is completed. These are all important methods we can apply on this or attributes, built in attributes which we can call on this series. Okay, you can see here index shape, data type, size, empty, has none, has n bytes. So when you look at that item size, of course, this is deprecated. We can remove this. Okay, we don't have item size these days. Okay, it's an old version of pandas. So what is index here? Defines the index of series. And then index, right? We already has discussed, right? But anyhow, this is just to get the result, not to pass in the series. Okay. So if you want to see some output, see some data on series, these are the important attributes we can call on this series. Okay. Let's quickly run through this. Index means defines the index of series. Shape means returns a tuple of shape of data, right? When you look at that output, you understand it. The data type means, returns data type of data. Size means return size of data. Empty means whether it returns true if series object is empty, otherwise false. Has nones. There is something called NaN, none values. So it returns true if there are any none values, otherwise returns false. Okay. And finally, n bytes returns the number of bytes in the data and dimension. What is the dimension? If you want to check dimension, that is written through this. That is the idea. Now, what is that? Let us check all these values. This is a simple example. So we are taking a list in the first example, and in the second example, Y, we are taking same thing, another list, but we are providing a customized index here. That is the difference. In the first example, X, we use default index. In the second example, just creating a customized index. Now we are testing all this, whatever we have just discussed here, that object attributes. These are not methods, just like what shall we say, built-in variables. We call on this series. Okay. Now we can quickly check this. You can see x dot index. So you see index output of x. And values, if you want to see all values, so you can call values method again. Again, we are calling on y. We can do one thing. We can quickly run and see. That's easy for you to understand. So now, I think I didn't copy. Let me copy this. Right click, run this. Now you can see here. Index, now you can see when you look at the output, you can easily understand what is this range index. So you can see this is having four values and the index starts with 0 because this is a list, right? And ends with what is that size -1. That is, it says stop 4. 4 means it will take till 3 because it has index with 0, ends with size -1. And then step increment, right? We discussed range function at the very beginning of Python. It is just showing that it's something like range. What is start? What is where to stop? And what is step? Step means by how much it increments. By default, the increment is 1. Got it right, friends? And these are values of that. When you say that x dot values, we are seeing the output of that list, that values of list. Same thing happens for y also, but difference is we have a customized index. So it is showing index as what here? So it is not showing start 0, stop 4 because for the first series, it uses default indexing for this list. So start is 0, stop is 4, step is 1. But in the second series, which is Y has a customized index. So it is showing that all that customized index here. And what is the data type here? These are all objects, because all this index is a string index, right? Labeled index, because that's why this is shown as object here. Or with as these are strings, string is an object. So data type of this index is, each index is object. And this is the value of that second series, which is Y. All that values are these, right? So it's showing that. Okay. This should give you an idea what is the index attribute doing. It is showing how the index is represented for each of the series. Among these two series, you can see the difference. Okay. Next, after that, this data type, anyhow, shape. Let's just run all this because these are simple examples. We don't need to wait much time here. Right. So, and one more thing, if you clearly understand series, even on data frames, you can find a similar thing. Okay. So you can easily understand data frames as well. Now we are again testing this data type. Data type just returns data type. That's all of that. This thing, no problem. And shape means probably it gives every value inside that, right? Probably when you look at output, that would be easy to understand more than. Let's run this now. Dimension means what is dimension of this series, okay? And size anyhow, n bytes. We'll see. Let's run this now instead of here. Now you can see the output here. So x dot n bytes, y dot n bytes. So total number of bytes it is occupying. You can validate it with 1, 2, 3, 4. Right? 8 4 32, right? Number of bytes. We just had discussed. Right? If it is an integer value, each one is what? Each one is 8 bytes int 64. You can see here it is showing. Right? In this, each one is int 6. This is the data type of X, series X, and this is data type of series Y. Got it, right? That should give you an idea. And each value inside this is 8 bytes. 8 4 32. That is what this is, n bytes. And next one, 3. It has 3 values. Again, that is also shown as int 64. Data type of, okay, sorry, it should be float 64 there. I was just thinking, because these are decimal values, right? Then the white data type should be float 64. But of course, let's run this now. Now you can see some change for Y data type. X data type is int 64. This one for this. For Y data type, you can see these are decimals and it is showing float 64, but still each value here, each value is 8 byte. So, and how many float values are there? 3 float values. And 8 3s 24 bytes. That is number of bytes actually. How many bytes it is occupying in that series? That is the meaning, total number of bytes. So that is the meaning of this these two. And size means, what is meaning of size? X size, Y size. The size of X is 4 and the size of Y is 3. Correct, right? Size of this one is 4. You can see 4 elements, 3 elements. Next, after that, dimensions. Both are one-dimensional arrays, right? Internally, both are one-dimensional. So, and shape. You can see the shape thing here. Shape in sense, simply speaking, total values inside that. This has 4 inside that. 4 comma means it represents it has 4, right? 4 values you can see here. 4 comma. And you can see this has 3 values, so 3 comma. Got it, right? In a way, internally it returns the dimension. Sorry, not dimension, that size. Implicitly it returns the size, right? It has 4, it has the second one has that is what shape does here. And finally, data types, looking at that, you understand these are decimals. So float 64, these are integers. It's choosing int 64. So this is the idea, just giving you how the internals are created for series. I'm just trying to make you clearly understand so that while doing development or anything, it's easy for you to play around that data, right? So let me share this also with you, right? Next insert. And you can play with that and see how it's coming and all that, okay? Now, next thing. So what is that next one? This example is also something interesting. What is it? We have a list with both regular values, like integer values and a NaN value. NaN generally we can use not a number or something like that. We can say none values otherwise. NaN is nothing but simply none, right? To check this nuns, we use to create a none values, we use numpy. NP represents numpy. NumPy by default have a built-in constant NaN so that we can add none values from NumPy. So when you are using this np.nan, you should import NumPy module and then just call this. Got it right, friends? Okay, fine. So this time we are also playing around this NaN values here, none values here. Okay. So now what do you do? We are also checking emptiness as well. See. So we created 3 series here. The first two are set with data. The third one is the empty one. So this print of A dot empty, B dot empty, C dot empty checks if the series is empty. You know, right? In the first example, we created an empty series. So if you want to check that emptiness of series, then you can just apply this attribute empty. And if you want to check if any of this series has NaN values, then you can apply A dot has nones, B dot has nones, this attribute. Length anyhow, we know we are much familiar with length, and count we know we are much familiar with count. Okay, so we'll just test this now. Let's copy this. So this will cover almost all core methods of this pandas. So not pandas series, not methods, attributes, sorry. Import, we need two pandas as PD and then import. Because I am using NaN, this NaN we are calling it from NumPy, this none. So first you have to import NumPy as NP. That is important. Now you can test all this. Now run this now. And just you can, somewhere there is a typo. No problem. That's a simple typo, not a big problem. Okay. Now run this now. Now you can see here, first one. The first one is what? Empty is if is A is empty, no. B is empty, no. But C is empty. That's why you got false, false, true. Has nones. Definitely A has nones, so it is returning true. And remaining two series don't have nones, it is returning false. Length of A has how many values here? 4 values, including none value. And B has 3 values. So that is 4, 3. And count. Count of values. See, you can see this is something really. What is that? When you say A dot count, it is excluding none. See here. And B dot count, it is, we have 3 values, it is taking that. So what is this count here? Count is something again. It's like number of values inside that series, excluding the none value here. It won't consider nones. Suppose you do one thing, you just add like 4, 5, 6. This time the count should give us 6. Altogether we have 7 values, but none is excluded. So count returns. This count is a bit different from the count we use in data structures. It's slightly different here. You can see this is giving count of actual values excluding none values. Total number of values inside that series. Okay, let's run this now. Now you can see 6 and 3 here. Okay, length will change definitely, but lengthwise, if you see, we have 7 elements inside that series, but count wise, we are seeing 6 elements because none is excluded from the count. Got it right? So this is the quick idea, friends. Understood now? So here this count is a bit different. Again, it's not same as the count what we have seen in string class or all other collections. Okay, just an FYI for you, so you can test this now. Next, after that, pandas. Another. This is something interesting example. What is this here? Pandas map. What is this map function? Right. This is something really interesting here. So a map function pandas is used to apply function dictionary or series to transform each element in a series. We can simply apply some transformations, data transformations using map function. Or you can also apply custom logic on that series using map function. Okay. And how do you do that transformation? We'll see with examples. How map. Already, if you remember, we had discussed this important advanced functions in functions. While discussing functions topic, we had a discussion about map function, filter function, reduce function, if you remember. So this map is almost same as the map we discussed while discussing functions. Okay, so this is similar to that. Now you can see map anyhow, the behavior of map is same. If you want to do any data transformations or by default, or if you want to do some custom logic and apply transformations, map is the best choice. And it takes two parameters, argument and NA is none. By default, it is set to none. Okay. So we'll see example. By example, you can easily understand. Use cases with map is we can pass a function as parameter, or we can pass dictionary, or we can pass series. We can do it in different ways. Now you can see here, we are creating a simple series with the 5 values here. Fine. Now you can see we are calling map on this series, and map, you know, right, and passing a simple lambda code snippet here. And the meaning of this is this map function will iterate every value in this series and then applies this operation. I mean, this is powered by 2. X to the, sorry, this is multiplied by 2. X into 2. Means it's nothing but doing squares. Squares of each number. 1 into 2, 2 into 2, 3 into 2. Right? Something not squares again. Again, it's just doing a product of 2. Okay, so it's a product, not square. Please ignore that word square. So that is what this is doing. When you look at this example, simple example, see, this is a simple example with map function. What this does here, it is just taking the series data and applying this functionality with lambda. Right? We know we had already discussed lambda is a function which we implement in a line. And here, what is that? Every time it takes one value, it applies this logic. Means it is doing a product by 2. This is nothing but multiplying all each value of this series by 2. That's what map does. Now you can see here we have 2, 4, 6, 8, 10. Is this a data transformation or not? Definitely this is a data transformation. Why? How is this a data transformation? Because earlier the values are 1 to 5. But now if you look at the output, the values are 2 to 10. In a way, it is doing a transformation on this data. That's what map does, right? So this is a very basic example. What is that this is doing is, it is transforming each of these values by whatever the value you are multiplying here. You are multiplying by 2, all this becomes like 2, 4, 6, 8. Suppose if you put 10, then you can see altogether a different data here. You got it right, friends. So that is the idea. So just sharing this with you. I hope you understand this now. Let me share this with you. Next after that, okay. Again, another example applied on map. What is that? Using dictionary. Now we have two examples. Suppose if you want to filter data based on a common element here, you can see there is some common element. You have this example, simple example. What is this? So the one is a series with a list of characters here, A, B, C, D. And another example is a dictionary with a key value page. You can see, so this keys and here this values in series are keys in dictionary and values in series are same, are common. Now what you are doing, you are calling data, right? This series, and on that you are calling map. To that map you are passing dictionary. Now what would be the output here? Output is interesting. All these common values are shown in the output. Let me just run it and show you here. So if you see the output, this is much more easier to understand. So just import this pandas for pandas as PD. Now let's run this now. What you see here, this is a bit interesting, right? So whichever are matching here between this series and this one mapping, all those values are displayed here. You can see A, B, C, D. So till ABC in data has a match inside mapping. You can see here, this A has a mapping, this B has a mapping, and this C has a mapping here. But D don't have a mapping, so it is showing it as none. So means these two are combined by the common column here. What is sorry, friends, we just had a power breakdown. I connected with hotspot. Okay, we'll continue. Can you hear me?
Yes, sir.
Okay, let's continue. See, this is here. Both this are combined with a common column here. You can see this series has A, B, C, D, and this mapping has A, B, C here. So these are merged with the common column here. So what is that matching here? This A, B, C as a match inside this dictionary. Whichever are matching, those values are displayed here. You can see here apple, banana, and cherry. But D don't have a match in dictionary, so that's why it's showing none here. This should give a clear idea how this map is doing. Map is helping us to map data, right, in this dictionary with the labels of or the values of this series. So that is one more use of map here. You can also quickly test this. So in a way, we are filtering data by using that map here. Next, after that, okay. Even this is almost same example. You can see here, right? You have two series. This is 1, 2, 3. This is 1, 2, 3. This is, I think this have proper match. All values are matching here. We have 3, and then that we are passing to map. We don't see big difference, but all values inside this, all the values inside list has a match inside this series. But this series is what? This series is internally a dictionary. Okay, we'll just test it to get that idea. Import. The difference is earlier we are directly using a dictionary to map it. Now we are using two series here. What is that? This is a series and this is a series. We are trying to map with them using map function. Now what happens if you run this? See the output. We have map for all values of series 1 in series 2, which is nothing but mapping series. So that's why we don't see any none values here. This is a simple example. This example, the difference is the previous example we use dictionary for mapping. This time we are using series for mapping. So that's all. That is the only change we have here. Next, let me share this with you so that you can do a quick check. Got it, right? This is how we can use map function to do some transformations on data, right? Next after that. So that's all about map function. So finally, you should get that idea. What is that? So the purpose of this is to do some data transformation. And if you want, you can also do this transformation by applying some custom logic, right? That is also possible. If you want, I'll show you that with some other example. Okay, maybe in the next class. But now let's jump to the next discussion. What is this? Again, standard deviation. There are few more important attributes we need to discuss. We'll discuss that and close this series scenario. And then tomorrow we can start with data frames. Okay, standard deviation is a simple one. You can see here we have a simple, but the only thing is this time we need to rely a bit on NumPy. NumPy to get this standard deviation on this, which one? On this series. Okay, let's do this. Now you can see, you can remove this. So this is another example. Now you can quickly run it. So what is this STD doing here? It provides a standard deviation. All of us know this. We learned this in statistics. Okay, that's what this does here. Next, after that, once we get standard deviation, now what you can do, you can also check how to convert series to frame to data frame. We didn't yet discuss data frame. Data frame is nothing but it has some rows and columns. So suppose you take a series, right? Otherwise, let that standard deviation be there. I'll share both in one this thing. And you can simply say import pandas as PD. Okay. Fine. This is fine now. This is the example now. You can see it's a very simple example. Right? What is that? We have a series with data, and this is nothing but a name for your columns. all columns. Okay. Now you are converting it to a data frame. To frame means convert series to data frame. So that's all. If you run this, see the output, right? So we are not printing this as start to frame. Just print it so that you can see that output. Okay. So let's run this now. Now you can see that. So you can this time what is it doing here? This is ABC and this is the index, and you can see that it is also having some what is it frames having a column name here. So this is column. Suppose you can do one thing. You can also add, yeah, let it be like that. So this is simply what it is doing is to frame method converts this series to a data frame implicitly. So that's why you can see here this is named with all these values, whatever you are sharing here. So that all those are placed under one column. That column name is vals here. So this is simple idea about what is this idea about